Hi students, welcome back to our class. Today we are going to moving into the one of the most interesting and slightly technical parts of explainable AI. So unit 4 attention mechanisms and then modular networks and feature identification. So before we jump into the heavy stuff, let me ask you something. So when AI model predicts something, say it's look an image and it says this is a dog. Have you ever wondered how it knew that? Like, did it focus on the dog's tail or the fur or the maybe the ears? We only see the result, but we don't know how what happened inside. So that's what we call a black box model. You see the input and the output, but not the logic in between, right? Now, as an engineer and the researchers, we don't want our AI to be a mysterious magician. We want it to be a explainable, something we can trust, debug and understand. So that's where these three topics come in. Attention helps the model focus, modularity helps the organize, and then feature identification help explain which features matter most. All right, let's slowly unpack each one. So starting with the attention mechanism. So this is your syllabus: attention mechanism, modular networks, feature identification, learn to explain, feature visualization, deep visualization, gradcam and activation map, finally sensitive analysis. Now we have only focused attention mechanism, modular network, feature identification for this PPT. So what is attention mechanism? So think before you that, okay, we have to, why explainability matters are here. So many deep models are black boxes. So explainability improve the trust and transparency of accountability. So the engineers and researchers, we don't know and we don't want our AI to be a mysterious magician. So we want to be explainable. Okay, so something we can trust, we can debug and we can understand. So that's where the three topics are coming. Okay, let's see the topic. The first one is attention mechanism. So what is attention mechanism? Okay, so what exactly is an attention mechanism? It is actually inspired by something all of us do every day: human attention. Okay, human attention. So think about this. You are reading your textbook and your phone buzzes. Do you read every single word on the page and the process every sound in the room? No, your brain filters things out. Okay, you focus only on the important parts. Maybe the sentences that is the bold or something a teacher you mentioned. Okay, so AI does the same thing because it is a human attention. So when you gives a lot of input like a paragraph, like a sentences or even a whole image, etc. But it can't process every detail equally. Okay, so it learns to focus more on certain parts of the input, so the matter most to the output. Okay, that is called as human attention. So mathematically you can think of it like this: output equal to summation of attention weight into feature value. So if something is important, it gets a higher weight. If not, the weight is small. Okay, so that's how the model like a transformers, GPT or BERT decided which words or image region deserve a more attention, right? So, and the small trick, just adding the weights, changed the entire field of AI, right? Okay, the next slide. Now the attention comes in different flavors, which mean the types of attention. So let's talk about the main three. The first one is soft, and the second one is hard, third one is self-attention. The first one, okay, we'll see one by one. The first one we have soft attention. So it is a smooth and continuous. The model does not completely ignore any part. It just give more importance to some part. For example, if you are translating a sentences, you might focus 70% on one word and then 30% on another. Okay, so note that if you're translating a sentences, you might focus 70% on one word, 30% on another. So soft attention is easy to train. So the gradients flow smoothly. And the second, we have the hard attention. So this one is more selective. Okay, so it says forget the rest. I will only look here, that concept. So imagine using a flashlight in a dark room. Okay, in a dark room we have using a flashlight. That's the hard attention. So it's more like you yes or no selection. Either focus or ignore. Either focus or ignore. This side or that side. Okay. But since it's a non-differentiable, so it's a trigger to train. So it doesn't play with all back propagations. And then final one is, yeah, there is a most famous self-attention. So this one completely revolutionized in NLP, natural language processing. In a self-attention, every input interact with other input. So in a sentence like the cat sat on the mat. Okay, we have to take a sentence. The cat sat on the mat. The model understand the cat and the mat are connected because the cat sat on the mat. Okay, that is a sentence. So cat and mat are connected. So that's how the model like bird and transformer understand the relationship and the context. Let me ask you, if I say the movie is not bad, what is the sentiment? Positive, right? So why? Because the word not changed the meaning of bad. So self-attention helped the model to catch the nuisance and the focusing more on not in the relation to bad. So that is called as types of mechanism. Okay. The next slide, why attention is useful. Okay, so why is everyone so obsessed with the attention? Because it makes more models transparent and interpretable. Okay, we can literally visualize the model focused using attention map or heat map. You have probably seen those pictures which part of an image glow red or yellow. So that is the model attention. So for example, if an AI model says this is a dog and the heat map glows around the ears and the tail, we know the model reasoning align with ours. So if the red area is somewhere on the sky or grass, then we know something's wrong. So attention is heavily used in image captioning, like generating a sentences for photos, and then transformers and a bird in text understanding, and then vision transformations for image classifications. So attention does not just make the model smarter, it makes it more explainable. The next slide. What are the next topic is modular network. So what are the modular networks? Now let's move to the modular network. So what is mean by modular network? So imagine, I have to tell, imagine you are working in a group project. You are doing a slide, one friend is doing research and then another is presenting. Everyone has their own role, right? That is the exactly how modular networks work. So instead of one huge deep network doing everything, we break it down into smaller parts, so called modules. So each module focus on one specific job or feature. So if you are designing an AI for self-driving car, one model could detect land, another detect pedestrians, another decide whether to accelerate or stop. By dividing the model this way, we make it more organized, interpretable, and easier to debug. If something goes wrong, you don't have to open the entire brain just to check the fault module. So that is called as modular networks. The next slide. There are the three main types of modular networks, and they are easy to remember. So first one is task specific modules, second one is feature based modules, third one is hierarchic based modules. Okay, so let's see one by one. So first one is task specific modules. So each module solve a part of the task. For example, in image recognition, one model might detect shape, another identify color, and the another matches the patterns. The second model is feature based model. Here each model focus on certain attributes. On one on edges, one on brightness, one on texture. It's like each has a specialized eye for different details. That is called as feature based models. And then hierarchical models. So these are layered simple modules. So these are the layered simple modules at the bottom, complex reasoning at the top. Okay, so simple modules at the bottom, complex reasoning at the top, like in the human brain. So first we detect the lines, edges, then shapes, then objects, then the full screens. Okay, so first we detect lines, edges, shapes, objects, and then full scenes. So you can see modularity is about dividing the and conquering. So both for performance and explainability. The next slide. Advantages of modular networks. So let's talk about the advantages. So why do we bother making these models? First one, easier to debug. So the previous example, the car example, okay. So the same car example we have to take here, easier to debug. So first one, if the car does not stop for pedestrian, we check the pedestrian detection model, not everything. Then second one is better transparency. So we can inspect each part independently. So each model's behaviors can be explained clearly. And then third one is reusability. So you can take trained model, say one that detect the object, and reuse it another project without retaining from scratch. Okay, so it's like a dividing company into departments, marketing, finance, HR, like that. Okay, so each can explain its own work. So when we combined, they form well organized and explainable system. So that is the main advantages of modular networks. Now here enter the beautiful part. Modularity also helps the explainability. Previous slide we have already seen what is modular network, so advantages of modular networks. Now we have to see modularity how can help with the explainability. So each module's a path can be traced and visualized. So if an AI doctor model predict a tumor, okay, AI doctor model predict a tumor, you can say this model detect the shape. That model analyze the intensity, and finally the model made the diagnosis. Okay, so everything is traceable. It's not a magic, it's a logic. So and that's exactly what we want. So AA that is not just powerful but understandable. Okay, so that is the example. So explainability in modular network. This is the way to help the modularity in the explainability. We go for next slide. Now let's move to the third big idea. First one is attention mechanism. Second one is modular network. Now the third big idea for fourth unit, feature identification. Okay, I have to ask a simple question. So if a student score 95 marks, what might be the reason? Maybe good preparation or regular practice or attending classes daily, right? So those are the features contributing to the output. Okay, so in machine learning it is also same like that. The feature identification mean finding out which input features contributed the most to the model's decision. Okay, so which input features contributed the most to the model's decision. For example, in predicting whether the person will get diabetes, okay, the feature could be age, BMI, blood sugar level, family history. Okay, so but which this really matters the most. So feature identification to help us that found. Okay, see the diagrams. We go for the next slide. Techniques for feature identification. Okay, so now how do we identify the features? So there are the some smart techniques are there. So you will see the names often. First one is feature importance. Second one is permutation importance. Third one is sharp. Fourth one is lime. Okay, so let's see one by one. The first one, feature importance. So common in tree models like a random forest. The model tells you which features had the biggest effect. And the second one is permutation importance. So we shuffle one feature at a time and see if the model accuracy drops. If it does, the feature was important. Then third one is sharp. Sharp meaning sharply addictive explanation. So comes from the game theory. So it fairly distribute the credit among the feature. Then fourth one is lime. Local interpretable model agonistic. And then it explained the single prediction at a time. So very useful to know why this one is example go that output. For example, in a healthcare shop might now show that the blood pressure and the age were the top factors in predicting the heart diseases. So doctors can actually see what's the AI considered important. Move to the next slide. So why the feature identification is so valuable? Because it builds that trust and accountability. When we know which features led to the prediction, we can spot biases. Like if the model is unfairly focusing on the gender or zip code. And then second one is improve transparency. Improve transparency means users can understand the result. And then third one is meet legal and ethical requirements. So especially in finance and healthcare. So if a loan application is rejected, we can explain it's a because of low credit score and income level, not just the model said so. So that's a responsible AI. When AI make a decision like approving a loan or diagnosing a diseases or classifying an image, we don't want it just to give an output. So we want to it show as the reasoning behind it, just like a student shows a step in the math exam. So explainable AI build the trust, transparency and accountability. So the first one is the concept, focus and contributions of three topics in XAA. The first one is attention mechanism. So where did the model looks? In a deep learning, especially in the transformers and the vision models, attention tells us the which part of input were important. If the model is classifying an image of a dog, the attention map show it was actually focusing the dog face or ears, not the background. The real world relevance in a medical AI, attention can show that the model focused on a tumor region in an X-ray. Benefit, it built the trust by showing the what influences the decision. The second one is modular networks. So how did decide? Instead of one giant black box model, modular network break the AI into small logical parts or stages. So each model has a clear role. For example, in a fraud detection, model 1 identity check, and then model 2 transaction behavior, model 3 location anomaly. So this allow the humans to trace which stage raised the alert. So the main benefit of this make the AI thinking the process structured and the traceable, like the following steps in a flowchart. The third one is feature identification. So why did it decide and that way? So this concept highlight the specific features that caused a decision. So in healthcare AI, it may say age, blood pressure, glucose level, and then are major contributing factors to this prediction. So it answers the question why the result. So the benefit help to justify the challenges and the AI's output based on the logic future. So the first one, attention mechanism, where did model the look? Second one, the modular network, how did it decide? Third one, the feature identification, why did it decide that way? Okay. So together the three concepts make a AI decision not only powerful but also understandable. The next slide, real world connections, okay, which means real world examples. So first one is vision transformers. So attention map show which part of image mattered, make a AI vision explainable. And then second one is healthcare AI. The feature identification highlights a key clinical risk factors, like a support doctors, not replaces them. Finance AA. So modular models show which step triggered by fraud alert and ensure the transparency for auditors. So the technologies are not just theoretical. They are actively used in critical industry that require a human trust and regularity clarity. Okay. They ask a human trust and regularity clarity. So across the industry, so the three concepts are to make AI system not only smarter but also human friendly and interpretable. Like so, students, what is the takeaway from the today classes? Mean AI should not be mystery box. We want that AI can explain its thinking like a good student showing their step in a math problem. What is that? Like a good student showing their steps in the math problem. So attention help it focus, modular network organize its thoughts, and a feature identification to help the justify the answer. Okay, feature identification to help the justify the answer. In our next session, we will move to the feature visualization, grad cam, and where we see what the parts of an image the model actually activated. It will be super visual and fun. Hope you understood. So AI, The final words, AI should not be a mystery box. We want to it act like a good student who show their steps, max steps. Okay. So the three concept, attention mean focus of the model, and the modular network means thought process, and then feature identification mean for justification. Clear? So these are the fundamental pillars of the modern AI, like a chat GPT, vision transformers. Okay. So in the next session, we will move the concept of actual visualizing AI using feature and a GradCam. Okay. Thank you. Make sure you revise the today topics. They are the foundation of understanding the explainable AI system. Thank you.